In the previous video, we discussed about definitions of whole number, examples and representations of whole number. In this video, we will discuss about properties of whole number. In this chapter, mainly we are discussing about 5 properties of whole number. So that are closure property, commutative property, third one associative property, fourth one distributive property, next one is identity. So these are the properties we will discuss in this chapter. So firstly, closure property. So let's see what closure property says on mathematical operations on the whole number. Firstly, in addition. If we considering any two whole number, if we add the two whole number, again we get whole number. That says the closure properties on whole numbers. That is, if we considering any two whole number like A and B, if we add these two number, we get C. It may be any whole number. So this says the closure property on whole number where A, B and C are whole numbers. Let's see the examples. So take any two whole number, so that is 5 and 6. If we add these two whole number, 5 plus 6, we get 11, correct? So here 5 and 6 are the whole numbers. If we add these two number, again we get 11. 11 is the whole number. So this satisfies the closure property. Okay, so let's move on to next examples. Take 9 and 8. So 9 and 8. So if we add these two whole number, that is 9 and 8, we get 17, correct? So here 9 and 8 are the whole numbers. Then if we add these two number, then we get 17. 17 also a whole number. So this says closure property is satisfied under addition in a whole number. It means conclusion, what we give conclusion here, closure property is satisfied under addition. Closure property is satisfied under addition. Next in subtraction. So same rules. If we considering two whole numbers, and if we subtract the two whole number, again we get, if we get whole number, that satisfies the closure property under subtraction. Let's see. Let's check the property if it is satisfied or not. So considering example, considering any two whole number, that is 5 and 3. So subtract these two number. 5 minus 3 is equals to how much we get? 2. So here 5 and 3 are the whole numbers. While we subtracting these two numbers, we get 2. Next, take another example. So 8 and 4. So 8 minus 4 is equals to 4, right? So here we get positive whole numbers. If we considering next numbers, that is 9 and 10. Subtracting these two numbers, 9 minus 10 is equals to how much you get here? Here you get minus 1 because 10 has negative sign here. So for that purpose in the answer we write minus. So answer is minus 1. So in the previous examples we get 2, 4 means positive numbers. These positive numbers are is belonging to whole number, but here in the third example we get minus 1. Minus 1 is not in the whole number. For that purpose, so what we give conclusion here? So therefore closure property is not satisfied under subtraction. Got it? So next, multiplication. So closure property is in a whole number, it's satisfied in addition, but it is not satisfied in subtraction. Let's see if it is satisfied in multiplication or not. So here consider the example. First example, 5 and 2. So while we multiplying these two number, we get 5 into 2 is equals to 5 2s are 10, correct? So here 5 and 2 are the whole number, we get 10. It means plus 10 means positive numbers. Next example, 50 and 3. So 50 into 3 is equals to 150, correct? Right? So 53 is a 150. So here observe 50 and 3 are the whole number. While we multiplying these two number, we get 150. It is also a positive number. So it is in the whole number. Next take another examples. 6 and 3. So 6 into 3 is equals to 18. So 6 and 3 are the whole number. While we are multiplying these two numbers, we get 18. 18 is a positive integer. It is in whole numbers. Then what we give the conclusion here? So therefore closure property is satisfied under multiplication. So closure property is satisfied under multiplication. Next, in division. So here also considering same conditions. So if we take any two whole number, if we divide the two whole number, again we get whole numbers. On that time only the closure property is satisfied in division. Otherwise it is not satisfied. Let's see or let's check. So considering any two whole number, that is 2 and 3. Here I am considering two whole number, that is 2 and 3. If we divide 2 and 3, what we get? So if we divide 2 and 3, what we get? So here 2 is lesser than 3. So it is not divide. So that what we have to do? you have to take decimal. So decimal, you have to take decimal point. Okay, so next you will divide. So 3 ones are 3, 3 6 are 18. So 3 6 are 18, you get 2, carry again 3 6, again you considering 20 and you get 6, 3 6 are 18. So what is the answer here? 0 0.6. So 0 0.6 is not a whole number. This is a decimal numbers. This is not whole numbers, right? So in the first example only we got right. So it is not satisfied means, therefore the closure property is not satisfied in addition, in division. If you want to clarification, you solve this condition in a more example. Let's take another example for this property. You consider another two whole numbers, that is 4 and 6. If we divide 6 and 4, you take 6 and 4. Okay, so 6 divided by 4. So here 4 ones are 4 ones are, remainder is 2. It means if we take decimal, it will become 24 5s are. So 1.5. Here also we get decimal numbers. So decimal numbers is not in whole numbers. So what we give the conclusion here? So closure property is not satisfied in division or under divisions, right? Finally, what we give the conclusion here? So whole number satisfy the closure property under addition and multiplication, but it is not satisfied, or satisfies the closure property under subtraction and division. Thank you.